Hello, welcome to the second part of the Strengthen and Extend work on surface area and volume of shapes and metric to imperial conversions. This is the questions that are a little bit more complicated and require a little bit more thinking about. So take your time with them and don't worry if you seem to be taking a very long time over doing these. There is some thinking time involved, so just do what you think is best. Okay, so when you're ready, have a go at this question and pause the video now and turn it back on when you're ready to find out how I did it. Okay, the first thing that I did with this question was I actually drew my trough. So let's go through this now quickly. A water trough is in the shape of a cuboid. It has a length of 1.5 meters, length of 1.5. It has a width of 0.7 and a height of 0.8. Water is put in the trough. The depth of the water is 3/4 of the height of the trough. So here's my water line, and I've marked it as 3/4. Work out the volume of the water in the trough in litres. Okay, so obviously the first thing that we have to note is that we're not measuring in litres at the moment, we're measuring in meters. So let's go through this a step at a time. In order to measure this as litres, I think the easiest way of doing that is to first convert all the units into centimeters, because we have a conversion factor for cubic centimeters to litres. So what I did was when I started doing this, I'm going to use centimeters, not meters. There's another factor that complicates it a little bit, which is the fact that the water is 3/4 of the height. So the first thing that I've got to do is find 3/4 of the height of my cuboid. So I know that it's 0.8 of a meter. 0.8 times 100, which is the conversion factor, gives me 80 centimeters. 3/4 of 80 centimeters, to find 3/4, I divide by 4, multiply by 3, and that gives me 60 centimeters. So this 3/4 here is actually 60 centimeters. Now I've got that, I can work things out. I can do 150 times 70 times 60, which gives me 630,000 cubic centimeters. The conversion factor, as we've already said, is that there are 1,000 cubic centimeters in a litre, so I divide 630,000 by 1,000. A nice easy division, and that leaves me 630 litres. So the volume of that trough, when it's 3/4 full, is 630 litres. At this point, if that's not what you had, please pause the tape, work your way through it, understand how I did it and what you have to do, and then return back to me when you're ready to carry on. Sorry. Okay, quite a big question, so take your time with this one. Don't be in any rush. This is quite a long question. Work through it step by step and you will find the correct answer. So pause the video, start it, come back when you're ready. Okay, now here there is quite a lot of writing. It took me a fair old while to explain this one, and that's okay. Sometimes questions do take some time. Don't be put off by it. The first thing that I did was I drew my diagram. So I've got 1.8 meters by 80 centimeters by 90 centimeters, which is the size of the tank. It also contains oil up to 25 centimeters. Can he fit 1,000 more litres into his oil tank. Explain your answer. Well, the first thing I did was I worked out the volume of what was left. So the 1.8 and the 80 are going to be exactly the same. I've turned them all into centimetres again. So the 180 centimetres by 80 centimetres is exactly the same. But what I've found is how much more space there is to fill. Now, if this total length here is 90 and I've already used 25, I've got 90 minus 25, which is 65 centimetres left. So the space that I've got left is 180 centimetres by 80 centimetres by 65 centimetres, 936,000 cubic centimetres. Again, we divide by 1,000 because it's centimetres to litres, so that leaves me with 936 litres. So no, he can't add another 1,000 litres because he hasn't got enough space. So that's that one done. So that's part A. Part B, he orders oil to fill his tank to 90% full. How much oil does he order? Right. For this, I've done another diagram. We know that this is just looking at the edge. Okay, that oil is still there. I've still got the 25 centimeters of oil there, but now he wants this tank to be 90% full. So he wants a 10% gap at the top. So 90% full. What is 90% of 90 centimeters? Well, to find 90%, we divide by 100 and multiply by 90. If we do that with this, we get 81. 90 divided by 10 is 9. 9 times 9 is 81. So altogether, when it's full, there's going to be 81 centimeters of oil from the bottom to the top. Now, at the moment, there's 25 centimeters of oil already there. So he needs to add another 56 centimeters. So the amount of oil he's going to add is 180 times 80, just as before, times 56, which is 806,400 cubic centimeters of oil. If I divide that by 1,000, I get 806.4. However, the question says, how much oil does he order to the nearest litre? So I have to round it down, obviously. If I look at rounding, any number, if this number is a 4, it's rounded down, so that becomes 806 litres. So he's going to buy 806 litres. That's my answer to part B. Part C, how much does he pay for the oil? Well, he needs to pay 70.2 pence per litre because it's under 1,000 litres. So I've got to do 806 times 70.2 pence. If I do that, I get 56,851 pence. That's pennies. Now, we don't often spend money like that, amounts of money like this in pennies. So at this point, you convert that into pounds by dividing by 100. If you do that, you get £565.81. And that's my answers. You may need to write some of this down, so pause the video, go through your work, compare it to mine, make certain you understand what you've done, and then return back when you're ready to carry on. Okay, a gold bar in the shape of a cuboid with a length of 150 millimeters, width 45 millimeters, height 45 millimeters. The bars melted down and made into cubes with side length 12 millimeters. How many cubes of gold can be made from this cuboid? Okay, volume question. Let's get started. Pause the video and work out your answer in turn it back on when you've got one. Okay, so this question, I'm just going to work my way through it nice and quickly. First thing I've got to do is find the volume of gold. So it's 150 times 45 times 45, which gives me 303,750 cubic millimeters. This is all in millimeters. Each individual cube, which is 12 meters a side, is 12 cubed. So 12 times 12 times 12, which is 1,728 cubic millimeters. How many cubes can I make? Well, I've got to take my 303,750 cubic millimeters and divide it by 1,728. And if I do that, I get an answer of 175.8 cubes rounded to one decimal place. It was actually, when you did it, you probably had a much bigger number to that. Now, at this point, we need to re-look at the question, because the question says, how many cubes of gold can be made? Well, can you make 0.8 of a cube? No, you can't. So even though normally you would round up with an 8, in this instance you can't, because you can only make 175 cubes. That is not a full cube. So the answer to this question is 175 cubes. If you wrote down 176 because you rounded it, you need to remember what's going on here. Sometimes we don't always round the way that we think, because we have to look at the context of the question. Okay, if that's not what you had, pause the video, write your corrections, make certain you understand where you went wrong, and when you're ready, rejoin. Okay, another question on conversions. When you're ready, pause the tape, and then we'll get going and look at the answers in a few moments. Okay, so an electric car travels 25 meters every second. How far will it travel in 1 hour? Well, to work that out, we can say, well, he's traveling for 25 meters every second. So in 1 second, so in 1 minute, it will travel 25 times 60. So that's how long it will travel. That's how long it will travel, how far it will travel in a minute. But we're not talking about a minute, we're talking about an hour. So we have to multiply this by 60 again to turn the seconds into minutes into hours. So 25 times 60 times 60 gives us 90,000. So the car travels 90,000 meters in an hour. Now, we tend not to talk about 90,000 meters very often. We try to use a different measurement. The measurement we would use is a kilometer. 1 kilometer is 1,000 meters, so I divide 90,000 by 1,000 to give me 90 kilometers. So the answer to part A, 90 kilometers. Part B. Ellie's electric car can travel 140 kilometers before the battery needs charging. Can her car travel 90 miles without charging the battery? Explain your answer. Okay, so what we have to do is to convert this 140 kilometers into miles. And if you remember from the last time we did this, the conversion factor is 1.6, and because we're turning kilometers into miles, we are dividing by 1.6. 140 divided by 1.6 is 87.5. So 140 kilometers is 87.5 miles. So no, she can't travel 90 miles without a charge in the batteries. This is the explanation as to why. By writing down the calculation, you can see why it works. So that's the only explanation that you need. Okay, if you need to write the correction, pause the video and rejoin us in a few moments. Right. Now this question is quite a difficult one to read because we have a graph. So I'm going to enlarge the screen as much as I can. Now it's really important with this question that when you pause it to answer it, you make certain you have this screen up because you need to be able to read the graph, so you need the screen to be as big as possible. So pause this video now, please, and then return when you're ready to answer it. Okay, so let's have a look at this question. The first thing that I have to do here, too far, there, is convert the number of gallons, the 500 gallons, into litres, because everything else in this question is all about litres. So I've got to turn it into litres. Conversion factor, as we know, is 4.5. So we'll do 500 multiplied by 4.5, gives us 2,250 litres. Looking at the graph, 4% of the milk is fat. So we have to find 4% of 2,250. 4% of 2,250 is 90. So 2,250 divided by 100 times 4 gives us 90. So there is 90 litres of fat in the milk. If you skim the milk, you remove 92.5% of the fat. How much milk is left? Well, we must find out what 92.5% of 90 is. So 92.5% of 90, 90 divided by 100 times 92.5 is 83.25 litres. Altogether, we have 2,250 litres, and if I take 83.25 litres away from it, I get 2,166.75 litres. Now, it may well be when you look at your graph, you might have read that as 5% or possibly 3%, but I think possibly 5%. I'm pretty certain it's 4%. I know it's 4%. But if you've written it wrong, if you follow my method and the way I've done it, you should be able to check your work. You should be able to turn that into 5% quite easily. So check your work and then make certain that you've done it properly. Okay, let's have a look at the next question. A cube has a volume of 64 cubic centimeters. The cube is cut in half to make 2 cuboids. What's the surface area of one of the cuboids? Okay, so we're going from this to this. It may help you to draw a diagram. It certainly helped me. So pause it, please, and answer this question. Okay, so here's my very rough diagram, and here is what I did. The first thing I did was I had to find out what the length of the side was. Now I know that if it's a cube, all the sides are the same length. So I'm looking for a number multiplied by itself and then multiplied by itself again that makes 64. The mathematical term for this is the cube root. So it's like the square root sign, only with a little 3 there. And the cube root of 64 is 4. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. So I know if this was a full cube, all of its sides would be 4 centimeters. If I split one of the sides in half, as I've done here, the side I've split is going to be 2 centimeters, but all the others are going to be 4. So, working my way through it, my side, 4 times 4 times 2 for 2 sides is 32. Top, and of course the bottom, 2 times 4 is 8, times 2 is 16. And the front, 2 times 4 is 8, times 2, front and back, is 16. So if I add those three together, I get 64 square meters. So the surface area of that cube is 64 square meters, which is the same as the existing volume. Okay, I'll put that back on. You might still need to see that. If you need to correct your work, there's the answers. Pause the video for a little while. Come back when you're ready. Okay, before you work your way through this question, I would just like to remind you to read this very, very carefully. Once you've done that, this question is much, much easier. So pause the video, answer the question. Put it back on when you're ready. So, I've got a bit of a framework on this question, but I'm still going to explain my way through it because it is a little bit tricky to get going. So, you've got a cake and you've got the dimensions of it, the outside dimensions of it, which are 12, 10, and 8. 1 centimeter, there's icing 1 centimeter thick on all the sides. So the actual dimension of the cake is actually 2 centimeters smaller. So if you've got a length of 12 centimeters, the amount of cake is 2 centimeters smaller than that, which is 10 centimeters. So 10 centimeters there to there, you've got 8 centimeters. You've got 8 centimeters of cake. And if you're looking at the height of it, if it's 8 centimeters in total, it goes down to 6 centimeters. I know it's a bit confusing. You don't often see cakes iced on the bottom, but this cake has been iced on the bottom. And it does say that in the part A hint. So it's really important that you bear that in mind. So armed with that, I worked my way through it. First thing I did was I worked out the overall volume, 10 times 12 times 8, 960 cubic centimeters. Then I did my 8 times 2, gives me 6. 8 minus 2 gives me 6. 10 minus 2 gives me 8. 12 minus 2 gives me 10. 6 times 8 times 10 is 480 cubic centimeters. So the cake has a volume of 480 cubic centimeters. If I take 480 away from 960, I get 480 again. So the volume of icing is 480 cubic centimeters. That's part A. Part B says, okay, instead of making a cuboid cake, we are going to make a cube cake. So all the sides are the same length. I'm going to make that cake the same volume as the icing. The icing has a volume of 480. So the cake must have a volume of 480. So now we're getting back to that last question. And we're going to do exactly the same again. We're going to do our cube root. So we're going to find the cube root of 480, which to 2 decimal places is 7.83 centimeters. Now you can't really measure, whereas you can measure 7.8 of a centimeter, you can't really measure 7.83 of a centimeter. Have a look at a millimeter and see what you'd have to cut into 3/10. So I would suggest the correct answer, or the most realistic answer to give, is 7.8 centimeters to 1 decimal place. That's the dimension. So it would be 7.8 meters high by 7.8 meters long by 7.8 meters wide, centimeters wide. There we go. And that finishes these sections. Please make certain that you've understood each of these last 3 videos, because when you return, your next piece of work is going to be a test based on everything that was done in Unit 2, which is all of this stuff. So spend some time with it, make certain you understand it, replay the tapes if you think you don't quite understand, and I'm sure you'll be absolutely fine when you do your test. Thank you. Goodbye.